This morning, I'm going to talk about deep learning on microcontrollers. So the first thing to note is it's a microcontroller. And the question you might have is, why are we doing machine learning or deep learning on microcontrollers? Because when we talk about machine learning in the press, or we look at articles in futuristic magazines, we see big shiny processors which are able to do lots and lots of compute. And you would ask, why do I care about something which can fit maybe in a very, very small form factor? Things we might be compute constrained, it might be memory constrained. And hopefully after this talk, you'll get a flavor of what are the use cases where a technology like this will be very, very useful. So before we get to the platform for running machine learning at the edge devices, we need to understand why exactly is machine learning moving to the edge. So when we look at the future of compute, maybe 5-10 years from now, what you'll notice is there is a trend of Internet of Things, and that is propelling billions of devices which are going to come up in a variety of use cases. Now, once you have these tens of billions of devices, and people always even say up to a trillions of devices, if they need to connect with the server for every use case they need to run, then it's not going to be sustainable. There's not enough bandwidth for you to connect for each of these devices to the cloud. It also costs power. Every time you send data from your edge device to the cloud, there is also latency. So something like self-driving autonomous vehicle, you don't want a latency where you send data to the cloud and back. And security is a big deal as well. So for use cases like health monitoring, sometimes you're not comfortable sending data to the cloud. One example is, let's say, if you have a security webcam, and every time there is an event, let's say your pet passes by, even right now, the state of the art is that you get a picture, a 5-megabyte picture saying that, look, something happened, right? You figure out what happened. And there is no reason why you can't put a very small neural net which can detect human, not human, and essentially cut down on variety of communication that still happens and save power, cost, and latency.